Hi guys, and welcome to another video. In today's video lesson, we're going to be looking at grade 11 exponents and surds, simplifying expressions using the laws of exponents from past examination questions, part 2. The question that we're going to be looking at today is from the November 2014 paper 1. And it reads as follows. It says, simplify the following fully. We got 3 to the x plus 1 minus 3 to the x minus 1 all over 2 times 3 to the x. Now, for this particular question, you can see your numerator is made up of 2 terms. Therefore, you have to factorize your numerator. So in order to factorize the numerator, the first thing that we have to do here is we have to write as separate terms. For an example, 3 to the x plus 1 can be written as 3 to the x. Let's just write that again. 3 to the x times 3 to the 1. We're basically using this rule of exponents. X to the m plus n is equal to x to the m times x to the n. Okay, and once we do that, you'll be able to see that we can remove 3 to the x as a common factor. So for 2.1, we're going to have 3 to the x times 3 to the 1 minus 3 to the x times 3 to the minus 1 all over 2 times 3 to the x. 2 times 3 to the x. We can remove 3 to the x as a common factor. We're left with 3 to the 1 minus 3 to the minus 1 all over 2 times 3 to the x. 3 to the x cancels with 3 to the x. So I'm now left with 3 to the 1 minus 3 to the minus 1 all over 2, which will leave me with 3 to the 1, which is 3, minus 1 over 3 all over 2. Remember, 3 to the minus 1 is 1 over 3. So therefore, I have 3, which can be written as 9 over 3 minus 1 over 3 divided by 2. 9 over 3 minus 1 over 3 is 8 over 3. So I've got 8 over 3, 2 over 1. Now I can write it as times 2 over 1 becomes half. So what I did there was I just changed my division to multiplication and I inverted this bottom number, which is 2 over 1 becomes 1 over 2. So now if we simplify, we get 8 times 1 is 8 over 6. 2 times 3 is equal to 6. And we can simplify further by saying 8 over 6 is going to be 4 over 3. Remember, 2 goes there 4 times and 2 goes there 3 times. However, if we wanted to use the calculator to double check our answer, we can also do that. 3 to the 1, so let's write that down. 3 to the 1 is 3, minus 3 to the minus 1 all over 2. Let's do that again, 2, and there we go. So we should have 4 over 3. Let's just double check, and there our answer was 4 over 3. Right, so my suggestions would be to use the calculator to check if the answer is correct, and then you can work it out manually thereafter. Let's look at the next question. It says solve for x. So here for this particular question, once again, we need to know our laws of exponents. Square root of x minus 2 to the minus 3 equals to 64. Law that I want to look at here is the following. Remember that if I have the nth root of x to the power m, it's going to equals to x to the m divided by n. So that's going to be minus 3 divided by 2. So I'm going to say x minus 2 to the minus 3 over 2. So let's write that down, equals to 64. And what is 64? If we write 64 with its prime base, it'll be 2 to the power 6. Remember, 2 to the 6 is equal to 64. Let's go write that down. X minus 2. So for 2.2, say x minus 2 to the minus 3 over 2 equals to 2 to the power 6. So x minus 2 to the minus 3 over 2, because remember we're using this law here, and 64 is 2 to the 6. So let's go look at this now. Now what we do from here? Well, from here now, remember that you want to get rid of this minus 3 over 2. So what we can do is we can now take both sides to this added this multiplicative inverse. Now the multiplicative inverse of minus 3 over 2 is minus 2 over 3. So what you do to one side, now you have to do to the other side, minus 2 over 3. Why multiplicative inverse? You see this rule here, x to the m, which is now raised to the power n, is equal to x to the m times n. The multiplicative inverse is such that when you multiply, you're going to get positive 1. And that's what we want to achieve. We want to multiply these two to get positive 1. But remember, what we do to one side, we have to do to the other side. So we're going to end up here now with x minus 2 equals 2 to the 6 times minus 2 over 3, which is 2 to the 6 times minus 2 over 3, leaves me with minus 12 over 3. So I'll have x minus 2 equals to minus 12 over 3 is minus 4, 2 to the negative 4. X minus 2 equals to 2 to the minus 4 is 1 over 2 to the 4, which is 1 over 16. Remember this rule here, x to the minus 1 equals to 1 over x. So now if we simplify further, we're going to have x minus 2 equals to 1 over 16. Let's simplify further. So we'll say x equals to 1 over 16. Minus 2, if we take it to the other side, will be positive 2. So x equals to 1 over 16 plus 2 can be written as 32 over 16. 1 plus 32 is 33 over 16. And I'll leave my answer like that. If I wanted to check my answer using the calculator, I can also do that as well. I can say 1 over 16 plus 2 equals to 33 over 16. And there you go. Okay, let's look at the last one in this question. So question 2.3 now. Rewrite the following expression as a power of x. So here we have x, and we've got a whole series of square roots there. And we've also got roots here at the bottom. So once again, the law that I want to be concentrating on is this one here. Right? And remember now that the square root of x is equal to x to the half. So working with that, or knowing that the square root of x equals to x to the half, we're going to start from the inside and work our way out. Remember that the 8th root of x over 7, that word equals to x to the 7 divided by 8, 7 over 8. So knowing all of that, let's see if we can work this question out. So 2.3 is going to be as follows, 2.3. So if we work our way once again, so let's look at this. So what would this be? The square root of x is x to the half. So let's write that down, x to the half. So here we'll have x to the half. And then the next square root there is, we've got also here, we've got the square root of x, which is also going to be x to the half. Okay, so this is now going to be written as follows. So here we've got x there, and that's to the half. And the last one here will also be, remember, we're going to have x to the half there. So let's cancel that one off. So that's going to be x to the half, like so. And then what's left? Yes, let's write that x down there, and then we've got in the bottom x to the 7 over 8. So we'll write down x there, all over x to the 7 over 8 equals 2. Now we're going to work our way from the inside out. So let's start here. Remember, this is 1, and that is half there. So we got x to the 1 times x to the half. Remember now that when you are multiplying and you've got the same bases, you're going to add the indices. So 1 plus half is going to be 3 over 2. So we're going to write down x to the, remember 1 is 2 over 2 plus 1 over 2 is 3 over 2. Okay, so we've now dealt with that. So you can now just, if you want to, I've dealt with that already, right? So that's half. Then we've got x down there. and we've got half again there, and that's x. We've got x to the 7 over 8, right? So now don't put a line like that in your examination. Now I'm just showing you this so that you can see what I've already dealt with. So here you've got 3 over 2 to the 1 over 2. Remember the rule that I just showed you now, that if you've got an index raised to a power, you're going to multiply. 3 over 2 times 1 over 2 is going to give me 3 over 4. So that's now going to be x there, and now I'm going to be left with 3 over 2 times 1 over 2 is 3 over 4. So that's x to the 3 over 4. And as you can see now, I'll be left with half on the outside there. Okay, and this will be x to the 7 over 8. So we're still working from the inside out. Remember now we've got 1 there, 1 plus 3 over 4. So we have to get the common denominator there. So 1 plus 3 over 4 is basically 4 over 4 plus 3 over 4, which leaves me with 4 plus 3 is 7 over 4. So I'm going to be left with x. And here I've got x to the 7 over 4 to the 1 over 2. And in the bottom I've got x to the 7 over 8. So now if I look at this, I've got x to the 7 over 4 raised to the power half. 7 over 4 times half will give me 7 over 8. So I've got x times x to the 7 over 8. 7 times 1 is 7, 4 times 2 is 8, all over x to the 7 over 8. What do you notice? X to the 7 over 8 cancels with x to the 7 over 8. And I'm finally left here with x. Learners, if you haven't subscribed already, subscribe to JL Maths, like my Facebook page, Justin Lazarus Mathematics, and you can watch all videos in order of the work schedule. jlmaths.com, and I'll catch you in the next video.